1 up here. Number 1. Does anybody remember what rule number 1 is? What? Mama, good. Everybody write that on your paper. M-A, M-A. Why is this one the mama rule? What's the clue? 2 sets of parentheses makes it the mama rule. When you see 2 sets of parentheses, you've got the mama rule. What does the mama rule mean to do? And add the little numbers. Good. So, are there any big numbers to worry about? No. If you want, you can put a 1, but you don't have to. Okay? You don't even have to worry about that. What is 1 times 1? 1. Okay? Then I'm going to add the little numbers. So, Haley, I would get x to the what power? Just look at the x's. So you've got x to the 3rd. What do you have over here? X to the... Got to put a 1 with it. Got to remember that. So it'd be total would be x to the 4th. Okay? Guys, everybody should have it on their paper. Put a little 1 with that x. Gracie, it would be y to the what? Very good. You add the little numbers. Very good. Anybody have a question on number 1? All right, number 2, Jesse, what rule is that? Very good. It is DS. DS, anybody, what does DS stand for? Good. Divide the big number, subtract the little one. So, Dylan, it would be A to the what power? What? Two. You got to subtract the little numbers. All right, guys, help me out right here. What am I doing with 3 and 5? Subtracting them. What do you get? 2. Very good. You get -2. You got to be careful on this one. What extra thing do I have to do on this one? Anybody remember?
Put the line.
Good. I have to put a line. Where is B going to go? Under. And remember, it's because which one's bigger? Is the 3 bigger or the 5 bigger? The 5. So B goes on the bottom. It goes where it's bigger. Okay? All right. Number 3. Number 3. This 3 goes to everything. This 3 goes to everything. It goes to the -3. It goes to the x. And it goes to the y. It goes to each separate thing. Okay? Here's what I need you to write. I need you to drop down the -3 in parentheses. I need you to drop it down. But what else goes with it? What did I just say goes with it? The 3. Okay? I'm also going to drop down the x, but I'm going to put the 3 with it. And then I'm going to drop down the y, but the y has 2 numbers. It's got a 2 and a 3. They're both little numbers. What do I do with them? Very good, which gives me 6. Okay? All right, Daniel, I have to do one more thing to get my final answer. What do you have to do? Do you remember? Yeah, what do you have to do with it? Power. Put it in your calculator. Parentheses, -3 to the 3rd. What do you get? Yep. But use your caret key. Good. -27. And guys, drop down the other stuff. X to the 3rd, y to the 6th. So, Number 4, Zaria, what happens when it's to the 0 power? Very good. And Zaria, what number do I have to put right here? Very good, Zaria. Number 5, Monica, what do I do on a problem like this? Very good. Yes, you put it in your calculator. 1 divided by 6 to the -2. Put it in your calculator. Andrea, what are you getting?
36.
Very good. Number 6, Ethan H. How do I do number 6? Very good. I put it in my calculator. Chuck, what are you getting for number 6? What do I want you to do when you get a decimal? Math, enter, enter. Enter. 1/4. Okay. All right, any questions on 1 through 6? All right, number 7. Chad, do you remember how I start this funky looking thing? Very good. You box in the first part. In my calculator, how do I get to the third root? What do you have to hit? Math. Very good. Everybody do this with me right now. Go to math. Go to math. Go down to number 4. Hit enter. And type in an 8. What are we getting? 2. All right. So that's where the 2 comes from in the answer. Does anybody remember the saying for this one? Jesse? Very good. Jesse, power over root. Okay, so guys, let's start with x. Let's start with x. What is the power with x? 2. Very good. So I put 2, and then I put a little division sign. So 2 is the power. 2's the power. Where's the root over here? Where's the root? Very good. It's on the outside. It's a 3. And guys, you can stop right there. Look at all your answer choices. Which one has x with a 2 over 3 with it? B. Okay? So don't make it harder than it is. Power over root. The power is up high. God is a higher power. Okay? All right. Number 8. Haley, do you remember what I do with 1/2 and -2? Very good. I multiply them. They're both little numbers, so I multiply them. Ethan H., what do you get when you multiply those two things? Good. Guys, drop down the x, but now you're going to put a -1. So you're combining these two things. You're multiplying them, and you get -1, but you have to drop down the x. You've got to drop down the x and put a -1 with it. Gracie, what do I have to do when it's a negative? Very good. So Gracie is going to be A, B, C, or D. Very good. You got to flip it. So it equals 1 over x. Okay. Number 9. Dylan, how am I doing number 9? Very good. I'm typing it all in my calculator because there's no letters. Dylan, tell us what you get. All right, so this one, when you type it in your calculator, you get 2. Okay, good. All right. Number 10, the sequence below shows how many trees Mitchell's nursery planted each year: 81, 27, 9, and 3. Which formula could be used to determine the number of trees the nursery will plant next year next if the number of bushes planted this year now is known? Chad, which number do I have to start with in the table? I'm sorry, in the list. Which one do I have to start with? 81. Guys, you have to start on the left. You got to start on the left. You got to start with 81. So, look at your answer choices to help you. What does this star mean you're doing? Multiplying. 81 times 3. What's 81 times 3? Y'all got calculators. I should see them moving. 81 times 3. All right. Is it 27? No. So you can mark that one out. Okay. What does B say you're doing? Good. Multiplying by 1/3. So you start with 81. What's 81 times 1/3? 27. Now keep going. You got to do the next one too. What's 27 times 1/3? 9. And what's 9 times 1/3? 3. So do they all work? So that one is B. Okay. Sorry about that, guys. Number 11, the population of Winnemucca, Nevada can be modeled by P equals 6191, parentheses 1.04 to the T, where T is the number of years since 1990. A says, what was the population in 1990? Monica, what do you think? How am I going to answer that? What's the population in 1990? Yeah, good job, Monica. That was a hard question, and you nailed it. 6,191. Somebody tell me why that's the answer. It's the y-intercept, or what else? What else do we call it? Starting value. And what year did it start in? 1990. So the starting value is the answer. Okay? All right. B, is it increasing or decreasing? Chuck, what is this one doing? Is it increasing or decreasing? Very good. Anybody, why is it increasing? What about it though? What about this number? It's over 1. Anytime that's over 1, it's going to be increasing. Okay? Chuck, how do we get the, oh, sorry, I just called you. Let me call somebody else. Andrea, how do we get the percent? What do we have to do? Do you remember? Okay, you got to type in. We don't want that anymore. Mark that out. We're done with that. That was our starting value. To get the percent, you look in the parentheses. Percent, parentheses. Type that in your calculator. 1.04. So when it asks for the percent, you look in the parentheses. So type in 1.04. What am I going to do next, guys? Minus 1, then what? Times it by 100. Andrea, what are you getting? So 4%. Okay. This next one, what would be the population in 2001? Daniel, how would I find the answer to that? What would I need to do?
Type in the 6,191, parentheses 1.04, parentheses, and you put in, what would that be?
All right, so let's just do this for now. So thank you, Chuck. Thank you, Gracie. I see y'all typing it in. Thank you, Dylan, Ethan, Haley. Lots of people typing it in. So you got to type in your y equals to answer this question. What will be the population in 2001? You would have to use your calculator. So you would type it in the y equals. Okay? All right. And then after you type it in, you always go to second graph and start at 0. So second window, we'll start at 0. All right, here's where you do have to remember. I'm not scrolling all the way down to 2001. Don't do that. What year did it start in? 1990. When you're given 2 years, like 1986, 2016, 1984, 2010, when you're given years, what do you have to do with the 2 years? You do that with years, okay? All right, so somebody tell me what that is. 2001 minus 1990. Thank you. All right, so in my calculator, I'm going down to 11. Jesse, what are you getting? Sorry, you got it? Ethan H., what you got? Good. All right, so 9,530. So that's how we would do that one. Okay. All right, the foundation of your house has about 1,200 termites. The number of termites grows at a rate of 2.4% each day. How long until the number of termites doubles? All right, Daniel, how would I start this problem? Very good, Daniel. I would write a y equals. That's how I would start every problem on my test. I would write a y equals. Zaria, what number comes first? How many termites did you start with? Yep, so that number comes first. Dylan, what comes next in my formula? Very good. What else, Dylan? Point what? 0.24 to the x. All right, guys, the reason I put this one on here is because this one is confusing. Somebody tell me something about this that's confusing. What word do you see? Doubles, okay? So that makes it confusing. So the termites, are they doubling per day? No. So remember how the x is the per day? So what's happening per day? What number goes with the per day? 2.4. So this is the number that goes right there next to x. Okay, so that's the number. That's how you choose what goes in the y equals, because that's per day. Now, it wants to know how long until the number of termites doubles. Well, how many termites did you start with? Okay, Now, we need to double this number. How do you double it? Okay. What is 1,200 times 2? So write this on your paper. Write 2,400, and I want you to put stars next to it, or dots or something. This is what we're looking for in the calculator. This number. This number right here is what we're looking for. 2,400. That's what we're going to look for in the calculator. So where are we going to put this? In our y equals. And then to answer their question, when will the termites double? We have to look for 2,400 termites. That's a lot of termites, okay? So let's look for that. And Haley, tell me what you get for your answer. 30 what? Days. 30 days. Okay. All right, so this one, again, to reiterate, how long until the number of termites doubles? You've got to figure out what it started at and double that number, okay? All right. Next one, what is the y-intercept of the graph of y equals 3 to the, or parentheses 5 to the x power minus 4? Gracie, how do I get the y-intercept of this? What am I looking at? What number? Very good. The 3 and the 4. So I have to do 3 minus 4. Anybody? 3 minus 4? -1. That's your answer. That's your answer. Number 14, Jesse, how am I going to do 14? Very good. So everybody should be doing this one. Go to math. Type it in just like you see it. I want you to type that whole thing in your calculator. You got to hit over again and put a 3. Hit a 3. Nope. Let's look at it. We got -5 for that. All right, good. All right, last one. We need to write function rules for each one of these. Number 1. Miss Patterson had 12 freckles when she was 8 years old. At the end of each summer, her freckles have tripled in number. Let X represent the number of summers since she was X years old. Chad, help me write a Y equals for this first one. What would my Y equals be? Very good. What's happening to her freckles? What are they doing? Do you remember what that means I do? I put a what? Very good. So triples means I put a 3. So that's your answer to that one. Number 2, Sam has 12 moles. He knows that the number of moles he has increases by 3 each year. Let X represent the number of years. Monica, help me with a Y equals for this one. What do you think it would be? Okay, so is there a percent? Okay, so increases doesn't mean to multiply. It means to plus. So I just put plus 3x because it's each year. So just 12 plus 3x. Number 3, Susan has $3 and her parents say they will give her 12 times that amount each year as long as she saves it. Let X represent the number of years she has saved her money. Andrea, help me with a Y equals for this one. What do you think it would be? Very good. What are you times them by? And then does your X go low or high? Very good. Last one, Joey noticed that there are 3 cardinals at his bird feeder. He observes the number of cardinals increases by 12. Let X be the number of days since Joey has been watching the birds. Chuck, help me write a Y equals for this last one. Okay, so parentheses are when we're multiplying or there's a percent. What's happening to the cardinals? What are they doing? What's increase mean to do? Just plus. So you put plus 12x because it's each day. Each day. Okay? This first one, is it linear or exponential? Exponential, because it has a exponent. What about this one? Linear or exponential? Linear because x is down low, so it's linear, okay? What about this one, Gracie? Linear or exponential? Very good, because it has a exponent, okay? This last one, Monica, linear or exponential? Very good, because x is down low. All right, good.